Good evening, students. This is Patnaik, your friend and tutor. And in today's session, this is going to be a one-shot video of the question paper that had appeared in your first semester for Pune University. This is academic session 23-24. I am talking about 2023-2024. Okay. So all of you who have given the paper and have got backlogs or KTs, you can watch the entire solution, very professionally made. And all those students who are going to write this paper of engineering graphics in their second semesters, pull up your socks. This solution is going to be very, very important for you. Okay, first of all, let us just browse through the question paper and we'll strategize which questions to select and which ones to reject. Okay, here we go. Let's do it. So there are as many as 8 questions, out of which you need to make only 4, right? So there is a choice between 1 and 2. You can go for question 2 or 1, then 3 and 4, then 5 and 6, and then 7 and 8. So as many as 4 questions are there, right? If you solve all of those 4 questions, you are going to get as many as 50 marks. Wonderful. Okay, so please read the instructions. Okay, and you need to make any assumptions if there are less data, right? Only in that case. Problem number 1 is from the topic of conic sections, and problem 2 is from involute. If you just read the problem number 1's description, it is a very simple problem based on the general method of parabolas construction. I would definitely go for this one, question number 1, for sure. Okay, I leave question number 2. It is a case of involute. Even here, the length of string is not equal to the circle circumference or the disk circumference. So the case is a bit advanced, where some advanced construction has to be followed. Okay, question number 3 and question number 4. Between them, I would go for question number 4. This is based on sectional orthographic. Although it is slightly advanced in the orthographic projection, but yet it is a very simple case. You can make the sectional front view, top view, side view with ease. Okay, so 2 questions done. 8 plus 16 will become 24. Now over to choice between question number 5 and 6. Question number 5 and 6, between them, let me just talk about it. The easier option is question number 6. This is a much more easier option because you are dealing with only straight edges. There is no circular profile. Students usually have a problem dealing with circular profiles and making their isometric views. Even if you watch carefully, here a flat surface is intersecting with the cylinder surface. So it might be a bit tougher for some of the students, but yes, don't worry, I'll provide you the solution. Okay, whether or not you attempt, you will be given the solution. And finally, between 7 and 8, the easier option is question number 7. From the outside, if you just read the description one, it would appear as if it looks like a very simple problem. Yet, there is a small trick involved. A lot of students get it wrong. Okay, so you have to watch that very carefully. Although it will take you around 5 to 10 minutes to make the entire solution, and you are going to get as many as 10 marks, right? If you are not confident with pyramids, then you can switch to the development of a truncated cylinder, which is problem number 8. So yeah, these are going to be my choices. Right, now let us talk about the topics from where questions have been asked. This is from conic sections, this is from involute, this is from orthographic projection, this is sectional orthographic, this is isometric drawings, development of surfaces, this is a case of pyramid, and this over here is a case of development of surfaces, cylinder. According to me, this is an easy paper, to be very honest with you. Let me rate all the problems on the basis of their level of difficulty. Question number 1, easy category. This is medium category, easy category. No, this is not easy category. I will put this in the medium category. This is easy for sectional orthographic. This is hard. This is medium. This is easy. This also is easy. As you can see, most of the problems are easy, right? And that's why the entire question paper falls in the easy category. Okay, all right. So now that we have browsed through the questions and the topics from where the questions have come, our strategy is very simple. We are going to go for question 1, question 4, question 6, question 7, right? These are the 4 questions that we'll be doing. Okay, that's our strategy. we just want to make sure that we solve the paper in less than 2.5 hours time. Okay, so the time factor is there, right? Don't get lazy while making these solutions, right? Secondly, we want to maximize our marks, and to maximize your marks, make sure that you choose the easy questions. Don't let your ego come in between. Only 4 questions to solve. Choose the easy ones and crush them, right? So before I go ahead with the actual solutions, I would want to let you know how you can access the PDF file of the entire 8 problems. Okay, the one-shot video. You just need to, by the way, have you downloaded and installed my application or not? If not, the link is in the description. Okay, if you can also access it from the web. You just need to enter the courses section, click over here in the engineering drawing graphics course, go to contents, and now just scroll down. English Hindi lectures are there. Right at the bottom there is university wise content. Click on it, and then you just need to select your university, which happens to be Pune University. Click on it. Again, scroll downwards, previous year question papers. As you can see, I have got April 2023 and October 2023, which is the first semester of the 23-24 session. So you just need to click on it. Okay, all the videos are also available. Apart from that, the PDF file, it has been kept unlocked for all my students on YouTube, so you can access it, right? So enough talking, let's solve all the question one by one. Chun ke banate hain sawalon ko. Here we go. Question number 1, and here we go. This is going to be rather an easy nut to crack. Problem number 1, and this is for as many as 8 marks. Bhai 8 number matlab free ke mil rahe, and we can easily crack this one in less than 5 minutes. You are going to watch why. Here we go. So we have to construct a parabola by the focus directrix method. This is also known as the general method. Okay, if the distance of focus from the directrix is 70 millimeters, so data is sufficient, you won't have any problem as far as the construction is concerned. What you need to do is you need to construct a parabola clearly stated in the problem using the focus directrix or the general method. So first of all, what do you know? Sir, we already know that the distance between the directrix and the focus is 70 millimeters. So what you have to start off with is by making this structure. Done. In this structure, please make this vertical line, which is popularly known as the directrix. And secondly, if you watch, this distance is the distance between a point on the directrix and the focus. This has to be taken as 70 millimeters. Similar, it's very simple. On this horizontal line, you need to make a point over here at a distance of 70 millimeters from C. That is your first thing to do, and you can then extend this line by 40 or 50 millimeters. By the way, this line is your default axis of the parabola. Done sir. Now in parabola, we know very well that eccentricity is equal to 1. That means distance of any point on the parabola from the focus to the distance of save point from the directrix, let's say C. Okay, this always is equal to 1. You need to find a point between C and F in such a way such that its distance from F is equal to its distance from C. So basically we are looking for the midpoint of CF. So midpoint can be located very easily. You know it is 70, half of 70, 35. Done. Now take the construction ahead by marking points at equal intervals of 10 millimeters. Okay, you can take it 15 millimeters also, you can take it 5 millimeters also. But I would suggest if this is 5, you should take this also as 5, this also as 5. If by the way this has been taken as 10, then the other point has to be marked at a distance of 10 millimeters. This is my suggestion. Okay. Anyway, so starting from this very point at equal intervals of 10, then 10, then 10, I have marked as many as 6 points, and through all of these points I have made vertical lines. Can you do this? Only the parabola will be bold and dark, or dark and thick. Okay, you can make this axis and directrix also dark, no problem. Whereas these construction lines should be very, very light, little grayish in color. You can use a 3H or a 4H pencil for that purpose. Okay, now what's up? We are going to make use of a compass. So with C1 as the radius, listen to this, with C1 as the radius, and now with focus as the center, you need to make an arc on this vertical line passing through 1, above and below. Simple, done. Now with C2 as the radius and with F as the center, and on this vertical line passing through 2, what you need to do is you need to make another arc, P2 and P2 dash. In the same fashion, now with C3 as the radius, with this focus F as the center, and on this vertical line passing through 3, okay, make a point, cut an arc above and below, P3 and P3 dash. In the same fashion, you can make the remaining points, P4, P5, P6, and when you join all of these points in proper sequence, when you join them, you get a curve which is popularly known as a parabola. It's that simple. Okay, start from this very point and on its way. Okay, keep it touching on the line for some distance, touching, and then divert away. Right, this is how you need to make your parabola, and the final drawing should look something like this, considering the construction aspect. Okay, please see the difference. See the difference. Done. First problem is done in 4 minutes and 41, 42, 43 seconds. Okay. Question number 2. This is based on an involute, and we are going to crack this very easily in the next 10 minutes. But as you can see, there is a choice between 1 and 2. It is better to go with question number 1. Okay. Anyway, problem 2. It is actually talking about an inelastic string. So there is this end P of an inelastic string, 160 mm long. It is attached to the circumference of a circular disc of 50 mm diameter. Okay. Draw the locus of free end Q of the thread if it is completely unwound from the disc. Completely unwound. Does not matter wound or unwound. The involute is going to look the same. And we are going to be applying this process of wounding the string onto the circumference of the circle. Right? Don't worry. Keeping the thread always tight. Name the curve. You already know the curve. I mean, the description of the problem is such that it is defining the curve. Okay, and the curve in this case is an involute. Yes, but you need to work out whether the length of string is greater than or less than the circle's circumference. I think it would be better if we can just start writing down the details which have been given in the problem. There is this end P of an inelastic string, 160 millimeters long. So length of the string has been given as 160. Secondly, end P is attached to the circumference of a circular disc. This disc is having 50 millimeter diameter. Done. Can you calculate the circumference, that is pi d? Yes, we can. This is what pi d works out as. And you can clearly make a comparison that the length of string is greater than pi d circle circumference. So a bit of advanced construction will take place. Okay, or point B will be slightly beyond point 12. If length of string is less than pi d, then point P will be slightly before point 12. Okay, you'll understand what I'm trying to say. Here we go. Let's start by first of all creating a circle. This circle is having a radius of 25, that is diameter as 50. First of all, divide the circle into 4 equal parts, and then you can keep your protractor over here, and then at an angle of 30 degrees, then at an angle of 60 degrees. You can see these are 3 equal divisions. The same process has to be repeated in all of these quarters, and when you do that, the entire circle is divided into 12 equal parts. Okay, you can number them from 1, 2, 3, 4. One more thing, when you do the construction, please number them as 1 dash, 2 dash, 3 dash, 4 dash. I forgot to do so. Okay, all right. now what we'll do is we'll simply draw a line from over here, from this very point. The length of the line is equal to circle's circumference, that is pi d, which worked out as 157.07. So make it as 157. You won't be able to mark 0.07 or go for 157.1, right? That's the best we can do. Okay. All right, so this is 157 basically. Okay, now our objective now is to divide this line into 12 equal parts. For that, starting from this very point, I'll randomly make a line at any angle of any random length. Okay, and then you need to make points. Keep a scale over here, and at equal intervals of 10 millimeters, keep on marking points. I'm making arcs, you can make points. How many? Sir, 12 points. When you've made the 12th point, connect it with this point. Done. Now keep your mini drafter, one scale of your mini drafter over here. Automatically the other scale will be perpendicular. Anyway, we don't need this scale. Now once your drafter is in this position, tighten the screw. Then bring it over to this 11th point. Draw a line. 10th point, draw a line. Keep on repeating the process until all the points have been exhausted like this. Now you can number them from 1 to 12. Okay, please remember these markings make a dash so that they are differentiated from these markings, right? Anyway, now what? Look, so the length of string has been given. How much? PQ is equal to 160 millimeters. How much is this? The line that we have just made is 157. That is pi d circle circumference. So point P is going to be slightly beyond this, not point P, but point Q. Please don't make this mistake. Let me go back. End P of the inelastic string is attached to the circumference of a circular disc. End P is attached, whereas end Q is free to move. So there is a difference. What we'll do is end P, that's the solution. End P is here. Let me show this to you. End P is here, and 160 millimeters away you are going to have end Q. End P is right here, and from this point at a distance of 160 millimeters there is going to be point Q. As I said, it is going to be to the right of this 12 point. Okay, this distance is close to 3 millimeters. This is 12 is 157 mm away, whereas Q is 160 millimeters away. I hope all of you got this. Now majority of the construction is done. Now what we've got to do is we've got to make tangents to all of these spokes. What we basically need to do is you need to keep one scale of your drafter over here, while the other scale will automatically be perpendicular, right? Tighten the screw also. So through one, with the help of this scale, draw a line. This automatically will become a tangent. This way, in case of 2 also, make a tangent. And through all of these points, in fact, you need to draw tangents. I expect you guys to make tangents easily. हो जाएगा? हो जाना चाहिए. Okay, now what's up? Now listen to this very carefully, and you'll also understand the reason behind the construction process from here on. We are wounding the string. Although in the question it has been given as unwound. Okay, does not matter. Let me tell you once again, unwound or wound, it is going to be an involute. Okay, identical involute in fact. When you start wounding this much portion of the string will come into contact. How much is left? Sir, from 1 dash to Q over here somewhere, we don't know. So with this much, from 1 to Q as the radius, with 1Q as the radius, and now with 1 dash as the center, with 1 dash, this is 1 dash, this is 2 dash. You keep the steel end of your compass over here and then cut an arc. This is going to give you Q1. Can this be done? Yes sir, this can be done. Okay, similarly, now with 2Q as the radius and with 2 dash as the center, cut an arc again. This is Q2. Done sir. Similarly with 3Q as the radius and with 3 dash as the center, cut an arc. This is going to give rise to Q3. Similarly, you can obtain points Q4, Q5, Q6, Q7, Q8, Q9, Q10. What about Q11, sir? This is from 11 to Q. With 11 as center, cut. This is Q11. So far, so good. As far as Q12 is concerned, this is from 12 to Q. Please take a careful look. For 11, this is the tangent, is it? And for point 12, this line itself becomes a tangent. So with 12 as center, you need to cut an arc, very small arc, close to 3 millimeters. Okay, so once again, let me zoom into this. If you watch carefully, this arc where it cuts on this red line, gives rise to Q12, where it cuts on the circle's circumference gives rise to endpoint Q. Okay, so these are the final 2 points. Done. Join all of these points in proper sequence. It gives rise to a beautiful curve, popularly known as an involute, and this is how the construction should finally look like. The involute, it's our objective, so it should be dark and thick. Okay, circular disc, keep it thick. The string, keep it thick, no problem, and then do the dimensioning as well. So in 9 minutes we have finished the problem. I hope it may appear tough to some people, but given the option of either doing a problem on parabola or doing a problem on involute, I would still suggest you to go for the parabola one. Anyway, I suppose all of you have understood how to crack this problem based on involute, where the length of string was greater than the circle's circumference. How much greater? It was this much greater, from 12 to Q, this much greater, right? And that is why you saw the involute did not finish here, it rather finished somewhere here. Okay, slightly more than one complete revolution, right? That's it. On to question number 3. And by the way, there is a choice between 3 and 4. Both of these problems are from the chapter Orthographic Projections. Question number 4 is a special case, that is sectional orthographic, wherein we cut the object and then make the projections. Okay, right now let's focus on question 3, and here we need to make the front, top, right hand side view and also provide the dimensions. And please note, consider a diameter 36 hole is throughout the object. This diameter, this hole is throughout the object. That means this distance is the cylindrical tube is having a height of 40. Along with that, this is having plate is having a thickness of 15. So 40 plus 15 will make it 55. Okay, so the overall depth of the hole, you can say, is 55, right, throughout the object. Please remember. I think we should go ahead and let us analyze this object. And first of all, we need to work out what are going to be the maximum dimensions, the maximum length, width and height. And based on this, we are going to make our boxes for front, top and side views. Take a look. This is the direction X. This is the default setting for the front view. So when you take a look at this from the front, here it is. Okay, you are going to see the maximum length as 100. The maximum height is going to be, please check, top to bottom of the cylindrical tube, this is 40. Then this plate thickness is 15. Forget about the plate thickness. This is where the plate starts, from here to this center, 45. And then this is a radius actually, okay, of a small arc. So this radius happens to be 25. So 25 plus 45 will make it 70. 70 plus this 40 will make it 110. So the overall length is 100, the height is 110, and the width is 90. Here we go. Let me start by making the boxes for a front view and top view. This is where we are going to make the front view. That's our location for top view. In front view, you know very well, this is the length, this is the height, 110. Secondly, this is the length, again 100, and this is the width, that is 90. All the dimensions have been given. If you want, you can take a screenshot of this. First thing is over. Secondly, we can connect these front and top views. And now let me produce lines from the top view towards the left hand side, rotate them by an angle of 45 degrees, sir, and then produce them in the upward direction. Produce lines through these points towards the left hand side, so that you have a box which is meant for right hand side view. By the way, this is for the front view, this is for the right hand side view, and this is for the top view, right hand side and the front view. Done. Okay, having worked out the dimensions of all the boxes, now we shall go ahead and find this center's location. If you watch, right now we are interested in creating the top view. In the top, you are going to see this center. This center is a center for the circles. There are going to be 3 concentric circles, let me tell you, as well as the center for the rectangle also. So half the dimensions 50, and this is 45. Half of 100, 50, half of 90, 45. Here we go. Done, sir. Okay. Secondly, if you watch, this is what you will see from the top, this edge. Yes sir, we can see this edge, and we are going to make this edge dark. Okay, how the projections look finally, you'll see that in the final slide, don't worry. Secondly, as far as these circles are concerned, okay, a smaller one is having a diameter of 36, the larger one is having a diameter of 72. 36 and 72 diameters. So in terms of diameters it's 36, but this in terms of radius is going to be 18, and this in terms of radius is going to be 36. Okay, half of 36 is 18, half of 72 is 36. I hope you can understand this easily. Secondly, students, if you take a look, this portion won't be visible from the top because this profile comes in between, so it's a hidden feature. Therefore we are going to represent this arc or this circular portion with the help of dashed lines. Now this is having a radius of 30, so again with this as center, make a circle of this sort. Okay, this radius is going to be 30. Done. All right, what's left, sir? One thing is left. There is a hidden edge. Which one? Here it is. Throughout the object, throughout the this width, 90 millimeters. So 20 millimeters from here 20 millimeters, again from here 20 millimeters. These are the two hidden edges represented by dashed lines. Top view is over. Now what shall we do? We shall go for the front view now. Here we go. I'm going to be making some reference lines. Okay, and this center line is very important for me. It is from this location that we are watching the object now, observing it. How do we go about our task? So this strip over here, 10 mm thick strip, would look like a rectangle. Okay, this overall length is 72, so this overall length is going to be 72. Then this thickness has been given as 10 millimeters, so this thickness is 10 millimeters, and you can make this rectangle. Very easy. So far so good, right? This actually looks like a cylindrical tube. Okay, there are two cylindrical tubes stacked one over the other, right, with inner and outer diameters. The second tube that I'm going to create is this one, right? So this is having a height of, this total height is, let me just zoom into it. Right now we made this. This is having a radius of 30, but how much is this height? So 40 minus 10 will give you 30. This way. Okay, this way. This distance is 30, please note, and this distance is 10, right? If you watch, we have made the front view of this cylindrical tube. Can you match the lines? I'm sure you can. Done, sir. Okay, and before this what we made was this one. I hope you are now able to relate which circle for which tube. Done, sir. And finally, we know very well, and it has been mentioned in the question, that this 36 millimeter diameter hole is throughout the object, cut throughout the object. That means this distance is 40 plus 15 is 55. So here this in totality is 40, and this is going to be 15. So that is how you do it. And yeah, let's go for it. This is having 36 mm diameter, so this is it. Can you match? Done. This is 15 millimeters. And now, sir, we are looking at the front view, and this is basically what we'll see. This is what we'll see. 100 by 15. So this is 15 by the way, and that's 100 for you. Done. Any other thing left, sir? These two points, right? These are the lines which we'll see from the front. These are the lines. So make these lines and outline. Done. So the front view is done. Now let's go for the top right hand side view. For that, we are going to take a look at the object from over here, right hand side. What to do now? Let me make a reference line. Okay, and can you see this center point? How high is the center point from the bottom? Sir, it is at a height of 25. So please make this plus sign, right? Why a center line? Because this, I mean, this is for a center, and the center is meant for an arc, right? Where is that arc? We are going to work it out. If you watch carefully, some students may be confused that, sir, it looks like this is a semicircle. No, this is not a semicircle. The arc starts somewhere here and ends over here. Rather, it looks as if this arc, or if you just want to make a circle, just think about an imaginary circle. This circle will have tangents through these 2 points. Okay, and we are going to do it in that fashion. So the radius is 25. Can you make this? Just a second. We are going to make that circular profile later. This from the front, and when you take a look at this from the right hand side, you are going to say the same profile. Okay, so the steps which we did in the front view have to be repeated over here. Then this tube here, then this hidden portion throughout the object here. And as far as the right hand side view is concerned, this is what you will see. So make it done. And now as far as the circular profile is concerned, using this as the center, make a circle of radius 25. Done, sir. And from these 2 points, don't make lines like this. Rather make lines in such a way that it becomes tangent, and from here also tangent. Okay, this way. And now brilliantly darken this portion. Again, use a compass. Okay, so the diagram is done. It is done. That's front view, that's the top view, that's the right hand side view, and your construction work, your dimensioning should look something like this. This is done. Okay, I have kept the font of the dimensions a bit larger so that you guys can visualize it properly. The dimensions are not usually this big, right? So yes, this problem is now done in about 11 minutes. Okay, thank you. Okay, so students, for question number 4, I have specially created a 3D solid in AutoCAD for all of you so that you can understand the object and the projections and the sectional front view in a much better fashion. As far as sectional front view is concerned, we are going to assume that a cutting plane is passing right through the center of the solid, just like this. And in this case, you have to create the front view, the top view, and side view. How can we accomplish all of these things and much more coming up in the session? So let me just take you to the question paper and let us read all the things which have been given. This is for 16 marks. Okay. Figure shows the pictorial view of an object using first angle method of projection. Draw sectional front view along symmetry line in the x direction, top view, left hand side view, and also give the dimensions. I won't be giving the dimensions. Okay, it is for 1 mark only. You guys can put the dimensions later on, okay, in your own manual drawings, right? थोड़ा सा मुझे काम करने से बचना है अब. Okay, you guys can do that. Okay, I think it would be better if I can just show you how the object is, and please note that you are going to cut the solid or assume the cutting plane passing through this line of symmetry. Okay, now take a look at this demonstration and enjoy. Here we go. Take a look. This is how the object looks like in the 3D environment. Now what we wish to do is we wish to bring in a cutting plane or a section plane, okay, which is going to pass through the line of symmetry that I just showed you just a few seconds back. Take it behind in this direction. You'll see this is what you need to do. Let me just, okay, and this from here you are going to make the sectional front view. Let me remove this section plane so that you can visualize it properly, right? Just a sec, keep watching. Hide it, and this is precisely going to be your final sectional front view. Okay, so don't worry. here we go. Let's start the problem. The first thing is you basically need to work out how much the length, maximum width, and maximum height is going to be. So if you watch, this is x direction is for the front, this is for the left hand side view, and that's for the this is for the top view, this is for the front view, this is for the left hand side view. I hope you're okay with this, right? The maximum length is 120, the maximum width is this much, that is 80, whereas the height is 20 plus this 60, which is 80, plus this much radius, which is 30. So 20 plus 60 plus 30 will give the value as 110. So please note that the length is 120, the width is 80, the height is 110. Let us start by making this box. You can take this distance as 2 centimeters and this distance also as 2 centimeters. Okay, that's how. Length, height. Once again, length, height, length, width. Length is, sir, it is 120. Height is, sir, it is 110 to be precise. 120, and this is 80. I hope I have made myself absolutely clear. Now what you need to do is connect the front and top view, the boxes. Okay, produce line, rotate at 145 degrees only, produce in the upward direction, produce lines from the box of the front view to the right. Okay, so this is the location for the front view, that's for the top view, that's for the left hand side view, right? Okay, so how do we proceed now? What we can do is, let me first of all mark this center. Sir, from the top, if you take a look at this arrangement from the left hand side, from the top it is 30 mm below, radius is 30. So right at the center, along the center line somewhere, 30 mm below, you can mark this center. This is 30. So secondly, if you want to figure out the distance from the extreme left, this is half of 80, which is 40. Okay, I hope using this information all of you can locate this center. Once this is done, let's get down to business. Let's say this is the point we are concerned. This is in the pictorial representation. Now this is the same point in the orthographic representation. How high? Sir, this is 20. Let me zoom in. Okay, sir, 20 above, 15 right, 35 above, 25 right. Okay, just do this. 20 above, 15 right, 35 above, 25 right, and then down by 35. Take it to the right, to this portion, down to the left, finish. So this much portion is what we've created just now. Done. Okay, sir. What's next? The next profile to create is what do we do? Okay, these 2 points, right? The distance between them is 20. So at a distance from here, at a distance of 20, you simply need to mark a point, and then you can go as high as this point over here and then join, right? What you've just made, let me make this very clear. Then the arc would look like a straight line, then the arc again, both of them would look like a straight line, and then this outline, that is the outline. Is this clear to everyone? Okay, done, sir. Now what? Now let us figure out all the hidden features or the hidden edges, and we are going to represent them using the dashed lines. We are watching it right now from the front, isn't it? Yes, sir. So there is this hidden feature or hidden edge, 120 mm. Sir, but what is this height? Sir, this height is 10 millimeters. So at a height of 10 millimeters, simply mark a point and then you can make this dashed line. Done? Okay, sir. The other thing to note is that there is an edge over here which is hidden behind this face, So you've got to give it some respect. With respect to this edge over here, you go down by 15 millimeters. There is this hidden edge. 15 millimeters downwards, there is this hidden edge. So here we go. This distance happens to be 1515. Done, sir? Okay. Once you're done with this, the hole drilled has a thickness or has a depth, you can say, of 20 millimeters. So if you watch carefully, this circle is having a diameter of 30. That means the radius is 15. 15 above and 15 below, you are going to make this dashed line. 15 above, 15 below. Done, sir. Front view is almost done. Now what we are interested in is the sectional front view. Okay, if you really want to understand the sectional front view, this is the portion which will be cut. Okay, then you go down, then this way, then this way, then this way. This is the portion you will see in the section. This is the portion you are going to see in the section this way, right? This is going to be how the section looks like. We are going to work it out. Right now, I am in the process of, or right now I have finished the process of creating the front view, right? I just want to show you how the hidden lines would look like. And once you section the solid, how the hidden lines disappear. Or rather, I should say how the hidden lines are replaced by solid lines. This is the transition that I wish to showcase to all of you. So front view is done, sir. Talking about the top view. In the top view, sir, we'll see this. Yes. We'll see this and this in the form of a straight line. Okay. In the same fashion, you can understand this portion also. Here we go. So darken it. Secondly, if you watch this edge over here, the projection of these three edges will be this, isn't it? At a distance of 15 from the left. So at a distance of 15 from the left, draw this. Done. How far? This is 25. So at a distance of again 25, draw. Done, sir. This is 20. Come forward by 20. Come forward by 20. 20. And then from here again 20. Do it. Done. What's left? Sir, this is left. This profile. This arc portion would look like a simple straight line. Where are you watching it from? Sir, from the top. This arc, although it is an arc, it looks like an arc from the side view. But when you look at it from the top, it would look like a straight edge. Okay, this is what I am trying to say. So keep your mini drafter aligned along this line. And then use your drafter this distance and this distance. This is going to be, how much is it? 10. This also is 10. How is it 10, sir? The answer is very simple. If you watch, the overall width of the object is 80, out of which this much is 60. How is it 60, sir? This is 30 radius, 60. So this is 10 is 70 plus 10 becomes 80. Now you understand. Okay. So you need to offset from here at a distance of 10 millimeters. You can make this simple. I hope this is simple to all of you. Okay. Yeah, 10 millimeters away, you can make this line and then join it, right? This, by the way, 10, 10, 20, 20, this way, 20. I hope you got the concept. What about the hidden features? Well, we are going to work it out. Take a look. At a distance of, this is 20, this is 20. 20 plus 40 is 60 plus 20 is 80. Okay. So at a distance of 20, there is this hidden feature. There is this hidden feature from both the ends, from here also and from here also. What's next? The next thing is you're watching it from the top. Again, this is what you'll see. Okay. 15 here and 15 here. So from this center line, 15 above, 15 upar and 15 downwards, you are going to make this hidden feature in the form of dashed lines, obviously. Is there anything else left in the top view? I don't think so. Now we can get going with the side view. This is the left hand side. Okay, we are watching it from the left hand side. Let's start from over here, and this is the point that I made on the pictorial drawing. Same point in the orthographic drawing. Okay. 20, 80, 20, 20, 10, 40, 10, finish. 20, 80, 20, 20, 10, 40, 10, 20. Done. Take a look at this point here, and then this point here. And now what you need to do is, you need to give this point some height, a height equivalent to 35 millimeters. So give it some height. Then to the right, travel a distance of 20. To the left, travel a distance of 20 again. Just do it. Then come down by 15 millimeters, come down by 15 millimeters, and then join. Okay. Side view is also almost done. Take a look at the center. What is the diameter of the circle? Sir, it is 30. So the radius is going to be 15. Center with a radius of 15 in your compass. Draw this circle. कितने का? 15 का. समझ गए? Okay. Again, using the same center, you've got to make this semicircle. The radius is 30. Again, don't worry. Keep one leg, pencil leg of your compass here. And then rotate. Okay. What did I just do? Keep one leg of your compass here, the pencil leg over here, and then make the semicircle. Now you see, you need to make this edge, but only this much portion of the edge is going to be visible directly. Okay, this much portion of the edge is going to be visible directly. This much portion, the portion beneath it, right, is going to be hidden by this face. Okay, so this much portion you are going to keep it, I mean, this is going to be hidden, this is visible. So the visible portion is a solid line. Here it is, solid line, and the hidden portion is a dashed line. I hope all of you have got this point. Now as far as the sectioning is concerned, let me tell you, we are assuming that the section plane is passing through this symmetrical line this way, and let me make this way, this way, this way. Here we go, and here we go. So this is how the section would look if I wish to color it. This is the part where you need to do the hatching. Here, this is the hole. Okay, no intersection between the solid and the cutting plane. This is what you need to do, and it would finally look like this. Wonderful. Okay, please observe how these hidden lines have been replaced with solid lines. Beautiful. Hidden lines replaced by solid lines, and that's the beauty of sectioning. You get to see the internal hidden details of an object, right? This was the transition that I wanted to showcase. Okay, this is done. Dimensioning is up to you, right? Do it. Mark at least 5 to 6 dimensions. You're good to go. And if you want to see the realistic orthographic projection, okay, because I had already created a 3D model, it would look something like this. Okay, so yeah, that's it. That's the entire problem's solution, and this is how you need to approach it. 15 minutes and 41 seconds. Yeah, I think your time is absolutely worth it. Okay, now let's take this question paper series ahead with another set of problems. This is based on isometric drawings, and this is going to be a beautiful one, yet it is tough. Okay, don't worry, and we all together can crack this. And let me tell you something, whenever you see tougher questions like question number 5 or even question number 6, yes, they can fetch you 16 marks, but I want all of you to make this drawing manually on a plain sheet of paper. Please do it. When you solve tougher problems for practice, life becomes easy for you in the examination. Please remember this. If you observe, you have been given the front and top views of an object. What you need to create is its isometric view. A very important question. Let me take you directly to the solution, and here we go. And by the way, whenever you start making any isometric drawing, okay, please remember to make these set of isometric axes, draw a vertical and a horizontal, and these lines, this line and this line, are at 30-degree angles. Okay, and then you can extend them in the backward direction, and this vertical line. Sir, when does this line come into the picture? This line over here. This line is this. All of these horizontal lines correspond to this isometric axis. I hope I've made myself absolutely clear. Secondly, sir, when does this isometric line come into the picture? Here it is, green, and match the green. Keep on matching the green, 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 green. And sir, what about this vertical line? Vertical line comes into the picture when we give all the points some heights. Okay, heights can be observed in the front view. Here it is. That is the height. That is a height. That is a height. And this is how you can keep on changing the orientation of mini drafter according to the dimension you are working with. Okay, whether it is along the isometric X, isometric Y, or along the isometric Z axis. I think we can go ahead. What is the maximum length? Sir, it is 132. What is the maximum width? Sir, it's 50. Okay, and if you watch, there is something else I need to tell you. This is 50. So 50 minus 16 will give you 34. Half of 34 is here, that is 17. Another half is here, that is 17. Same is the case over here, 17, 17. This, by the way, is 22, 22, 22. This over here has already been mentioned, 16 and 16. Okay, let me copy this on the next slide. Here we go, 17, 17, 22, 22, 16. No, that's not 17. 17, 17, 22, 22, and 16. Let me zoom in so that you can have a closer view of these sort of extracted dimensions, isn't it? Okay, so the first thing is to make a point. Here it is. We've marked a point. Okay. Now, how much is the length? Sir, it is 132. Parallel to this line. 132, 132, 132. Done, sir. How much? Sir, 17, 17, 17. Done. Then 22, sir. 22, 22. Okay. 16, sir. 16. Okay. 16, 16. 22 again. 22, 22. Done. 17, 17, 17. Okay. you must be laughing. Again, this line over here, that is 132 again. 132, 132. Okay. I'm just giving you the hint how to place your mini drafter parallel to this line, 132, and then close it. Okay. This way, this is you don't get to close it right away. Rather, you have to travel 17, 17, 17, 22, 16. I hope you've got the idea. 22, and then close it. 17. Done. Yes, sir. Good to go. How do we proceed from here? Now what we can do is we are beginning by creating the entire top view first, and then gradually we'll be providing the heights. Okay, as given in the front view. Don't worry about that. The center, I mean, this can be located very simply. This is 50, so half the center would be somewhere along this line. This line is at a distance of this is 25, isn't it? Half of 50. Secondly, this is 132. Half of 132 is how much? 132 by 2. Okay, let me just write this as 132 by 2. So this has got to be 132 by 2. So you are going to locate the center this way. Okay, let me mark the center. Sir, what about these lines that you've just made? What are these lines? These lines actually represent the radius in isometric. Let me give you an idea of this. This larger circle over here is having a diameter of 66. Half it. 33 is the radius. So 33, 33 this way. Okay. And then 33 to the left, 33 above. Done, sir? Very well. Cover it this way. I mean, keep your drafter along this line. Make this line and this line. Similarly, these two parallel lines. So sort of it will be enclosed inside this rhombus. Okay. In fact, if I can just show you this a square, isn't it? The isometric view of a square is a rhombus. That is what we've just made. And inside the square, there is a circle. And you know very well that the isometric view of a circle looks like an ellipse, isn't it? right? And that is what we'll be making. Now, whenever you do this construction, there is a larger diagonal and a smaller diagonal. It is the smaller diagonals corners that we are interested in. So we are talking about these two corners. Choose anyone to begin. The opposite two sides will have these 2 points as the centers. Connect. Similarly, choose this corner. The opposite two sides will have these 2 midpoints, not corners, midpoints. Connect. Now, these are the intersection points. With this much as the center and with this much as the radius, rotate. Then with this as the center and with this as the radius, rotate. Again, center, radius, again, center and the radius, rotate. Isometric view of the circle is done, but this in fact is a cylinder. Okay, it should look like a cylinder. And then there is a depression over here. Can you see these sort of dashed lines? They represent hidden feature. So there is a depression, right? Gadda hai wahan pe. Samajh gaye? Okay. The hole has a certain amount of depth. We'll talk about that, don't worry. So far so good, sir. What is next? Here it is. If you observe carefully, all of these points in the top view are having a height of 12. Okay, all of these points also have a height of 12 millimeters. So I am going to raise all of these points by 12 millimeters, and this construction is going to repeat itself 12 millimeter above this way. Done, sir? But sir, what about the cylinder? We'll be gradually giving the height to the cylinder also. You need not worry. Let's do that. First of all, let me give the cylinder, give the circle a height of 12 millimeters only, so that we can reach here. Okay. So what we'll do is, let's take this point. For example, let me give it a height this much. Okay. Similarly, what I can do, I can choose another point and give it also one height. Choose this point, 12 millimeters. Choose this point, 12 millimeters. 12 millimeters, yes. Choose this point, 12 millimeters again. So I'll have a number of points. All of these points are at a height of 12 millimeters. Okay. And when you connect all of these points, you have to do it very, very professionally. You don't need to make these lines. Rather, I would suggest you keep your mini drafter absolutely vertical, and then at a height of 12 millimeters, make a point. Okay. Keep on making points. Once you have sufficient points, connect all of these dots with the help of a smooth curve like this. Smooth curve like this. Beautiful, isn't it? Okay, sir. Now, let's say we are here. When I say we are here, that essentially means the lower circle, the lower ellipse that you see. This is the point, what I'm talking about. From here, you need to travel a distance of, total distance of 44. This distance is 32, but right from the bottom, it's 44, 32 plus 12. Okay. So from here, 32 plus 12, that is 44. Okay, so now what? But if you want to work out the distance, this distance over here, this is 32. Let me make the classification. This is 12. Am I clear? Yes, sir. You are. At a height of 32, again at a height of 32, again at a height of 32. Keep on making points at a height of 32s. Maintain the consistency. 32, 32, 32, 32. Once you have enough points, join all of them. Right? Once you have enough points, join all of them, and again you are going to get a circle. Now you can clearly see that there seems to be a lot of confusion. You may end up in a lot of confusion if you don't keep your work light. What I essentially mean to say that in order to take this construction ahead, I have to get rid of some of the construction. Okay, so that I as a teacher can give you a good perspective of how the entire isometric drawing looks like. Check this out. Once again, check it out. Okay. So this elimination of all of those lines which eventually won't be seen in the isometric view gives us a lot more clarity. Okay, but we need to bring more clarity, and in order to do that, I am going to get rid of this curve also, which actually falls behind this curved surface or lateral surface of the cylinder. Chumantar. Okay, one more thing is left. What about this? Why is there an edge? There is no edge over here. So get rid of it. Done, sir. Very clean. Now our drawing looks very, very clean. Now again, we need to locate the center. Okay. So what you can do is keep your drafter parallel to this line. This way. Again, parallel to this line. Parallel to this line. Make a line of this sort. Then parallel to this line. Make a line of this sort. And then wherever they intersect. This is where they will intersect. And from here, I can zoom in. This smaller circle is having a radius of 40. No. The diameter is 40. The radius will be half of it. That is 20. So from here, 20 to the right, 20 to the downward direction, 20 to the left, 20 to the right. Up 20, 20, 20, 20. Enclose it. From here, 2 lines. From here, 2 lines. Done. Now, center point and radius draw. Similarly, center point and radius. Use a compass. Draw. Center point, radius, draw. Center point and radius, draw. Our circle is isometric view of the circle is done. And now we are going to get rid of the construction. Now we can see this circle actually is right at the top and it has a certain amount of depth. How much is that? What dimension can you see? Well, this is not my fault. This is the fault of the one who has set the question paper. The dimension cannot be seen clearly. Looks like 0. If you just try to make a comparison between these two dimensions, this is 12, this looks like a bit smaller than 12. So I am going to assume that this dimension is 10. Okay. अब कुछ दिखाई नहीं दे रहा है तो मैं क्या करूँ, जिसने भेजा है क्वेश्चन पेपर, आई एम श्योर ये क्वेश्चन पेपर में आपको करेक्ट कराया होगा in the final examination, but yeah, we are going to take it as 10. So 10 mm below, make a point. 10 mm below, make a point. This way, 10 mm below, make a point. 10 mm below. Please, you have to go through this drill. Okay, you simply need to make points and not draw lines. Simply mark these points. And once you have got enough points, and once you're confident that I can pass a smooth curve through all of them, pass it. Right? What do you think? Is this the final view? No. Only this much portion will be remaining, whereas this portion won't be seen as it is falling below this place over here. Okay, so let me get rid of it, and this is what remains. That's the final isometric drawing. Okay, use a edge pencil, the final touch up. And if you want to see the construction, okay, some teachers get annoyed if you erase all the construction. Don't do that. Keep the construction alive. Okay, just alive. Make sure your construction work is very, very light. Use a very light sort of grayish pencil. 3H pencil will do the job for you. If 3H is dark, then go for 4H. Your choice. Different companies I've seen have different level of darkness, so that is the problem you have to deal with, but you can work it out. Okay, light means light, dark means dark, and your construction along with the isometric is like this. Wonderful, isn't it? If you can make this drawing, I can guarantee you are going to get 16 marks for sure. Okay, that's all from my side for this very problem. Now we are on to question number 6. This is also based on isometric projection. You basically need to make an isometric view, and here is the problem. The moment you look at this orthographic projection, you are bound to get confused. There are so many lines. In fact, whosoever has made this question paper has certainly failed to recognize the difference between an outline or a solid line and a projector line. Because if you take a look, this, if you extend this should be referred to as a projector line. Okay, and then we are rotating it at a 90-degree angle over here. This also, in fact, refers to a projector line, but still it has been darkened. Looks like a solid line. it gives us an impression that there is an edge over here. So, but you don't need to worry. I have made all the necessary corrections. Just take a look. The original diagram is this. These are the outlines and the edges which are visible in the front, top and the right hand side view. If you want a much more clearer picture along with all the dimensions, this is it. Okay. And this basically is question number 6. Please tension mat lo. This is question number 6. Okay. Don't worry. Based on this diagram, we are going to be creating our isometric view. But first of all, we need to understand what the maximum length and width is. Okay, we are going to be creating the top view first in isometric, and then gradually we'll be giving all the relevant points their heights. Here we go. Just take a look at this first of all. Let me go to the next slide. What is the length? Sir, length is 80. What is the width? It is 60. Now there are going to be two options. Option number 1, you can choose the length over to this side and width over here. That means you can choose length as 80 and width as 60, right? So the top would be something of this sort. Then there is another option. You can select the length over to this side and you can then select the width over to this side. This is a much more better option. The reason being very simple. Let me explain this to you. Length is 80 and width is 60. You see this profile over here. You must always make the isometric view in such a way that all the features, profiles or elements of the object are clearly visible. Take a look at this over here. This arrangement, if you take 80 over to this side, will be here. It sort of will be in the back of the drawing. Okay, the way we look at it. But if you choose 80 along this axis, this isometric axis, in that case, this sort of triangular prism kind of a profile that you have will appear somewhere here. So that's the benefit. Take 80 mm to the left and 60 mm to the right, length to the left and width to the right, length to the left and width to the right. That is the first thing. Then what you need to do is move parallel here. Note these isometric lines are going to help you align your mini drafter. Okay, and then connect. Now what should we do now? Sir, this by the way is 80. Okay, point in the front view. In the top view, right at the base, there are 2 points. Let's say this is 1, this is 2. When you look at these 2 points from the front, they appear over here, 1 dash and 2 dash. So I can write this as 1 and 2. Now these 2 points will be given a height of 60 millimeters. So let me give them some height. Done? Okay, sir. Now let's say this point corresponds to again 2 points in the top. Let's call these 2 points as 3 and 4. So these 2 points at the top are 3 dash and 4 dash. So let me write it down, 3 and 4. So these 2 points, it looks like a point, but there is a line, there is an edge. So connect. Done, sir. Now what? Now you need to come forward in this direction. Okay, how much is it? Sir, it is 20. So this way. Done. And again, you can see it looks like a point, but there is in fact a line. There is an edge over here. So join with the help of an edge. Done, sir. Now we can clearly see we are right here. Here, 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 here. Okay, let me write this as 1, 2, 1, 2, 1 dash, 2 dash. Let me name these 2 points. 3, 4, 3 dash, 4 dash. So that's 3, that's 4 join. You should be able to relate all of these things. Okay. Now I am not going to talk in detail. This, by the way, is a question for 16 marks, and it's a very easy problem. I am shocked that whosoever has set this question paper has given 16 marks for this problem. It does not deserve 16. It does not deserve more than 8 or 10 marks, not more. Okay. In fact, the first problem on isometry, the question number 5, was way tougher, right? but again, you always need to select the easiest option. Okay, good to go. Now you see this. Yes sir, what is the height? Sir, it is 30 millimeters, so 30 millimeters, and then you are here. Produce a line in this direction in the isometric until it intersects this slant edge, somewhere here. We are good to go. Now let me remove these edges as they won't be visible. Why? Because they fall behind a plane or a surface. All okay. Now this is the point that I'm concerned about. You need to come forward by a distance of 30 millimeters. From here also you need to come forward here 30 millimeters this way, and now you can simply join and finish it off. Your diagram is done. Okay, there will be an edge over here, and yes, if you darken it, this is how it would look, and along with this construction, this is how it looks, right? Don't erase the construction lines, rather override them with the help of solid lines wherever it is necessary. Okay, yes, that was the problem in almost 7 minutes. 16 marks in your KT. Very easy one. So the next problem, that is question number 7 and 8, are from the chapters. Both of the problems in fact are from the chapter development of surface of hollow solids. And let me tell you very honestly, question number 7 and 8, both of them are very easy. I would have gone for question number 7 because it's even easier than the 8th one, right? Very less complications, very less effort to make the construction. Okay, let me just read the question for you, and then we are going to do this in less than 5 minutes. Here we go. Draw the development of the lateral surface of a hexagonal pyramid having base as 30 mm, axis height as 80 mm, kept on HP in such a way that one of the base edges is perpendicular to VP. Wonderful. But one of the base edges perpendicular to VP. Very well. First of all, we are talking about a hexagonal pyramid. That's the first thing. The dimensions are the base edges. All of these are 30 millimeters each. Secondly, the height of the pyramid, or let's say the length of the axis. This is equal to 80. Okay, remember 30, 80, 30, 80. All right. Base is on HP, and the one thing that has shocked me, that although it is a question from the topic development of surfaces, there is no cutting plane or section plane involved. It's a very easy question for you. You just need to develop it, right? It's a hexagonal pyramid. Therefore, in the development, there are going to be as many as 6 triangles. So damn easy problem. But still, there is going to be a certain amount of trick which will be revealed in the next few seconds. Make a hexagonal pyramid, and it has been given in the question that one of the base edges is perpendicular to VP, and you can clearly see this base edge. What, sir? FA base edge. You can clearly see it is, yes, it is perpendicular to XY line, which means it is perpendicular to VP. You can also say, sir, along with this, ये तो free का perpendicular हो गया, बिल्कुल. CD also has become perpendicular to XY lines, which indicates it is perpendicular to VP. Done? Okay, sir. Let's make the projectors. By the way, these are the slant edges first of all. Okay, meeting at the center, and then draw the projectors. These are the points of the base, and then the axis length is 80. Okay, I'll be doing the dimensions at the end, don't worry. And then join. Done. Now you just need to make the development. Please remember, whenever you solve a problem on development, you have got to use or make use of true length. There is a check. Please check whether any slant edge is parallel to XY or not. If the answer is yes, then the corresponding front view is true length. Please note it down, or you can take a screenshot. If no, then select any slant edge and make it parallel to XY. Okay, and then its corresponding front view is going to be your true length. So this is the process. Allow me to explain. Okay, as you can see, OF, just a sec. Take a look. Is OD parallel to XY? No, sir. Is OC parallel? No, sir. Is OB parallel? No, sir. In fact, this is perpendicular. What about OA? No. OF? No. OE? No. So there is no slant edge in the top view which is parallel to the XY line, and hence, is slant edge parallel to XY? The answer is no, and therefore we are going to take a look at, we are going to follow this condition. We are going to select any slant edge. In our case, we are going to select this slant edge OA. We are going to make it parallel to XY. So what we'll do is we'll rotate it, rotate OA until it becomes parallel to XY. Take a look, take a look, zoom over here, take a look. This is what we've done. If you watch carefully, this was the initial location or position of OA. We have rotated the solid in such a way that this OA has now become OA1, which indicates that it is parallel to XY line. Now, if you watch this O dash, A dash, this is old stuff. The new stuff is O dash, and this A1 is going to have a new location in the front view. This is A1 dash. Let me zoom on it. What is this? This A1 is going to have a new location in the front view, that is A1 dash. Okay, just like A was connected to O, you have to connect A1 dash with O dash, and this now qualifies as your true length. I hope I have made myself absolutely clear. A dash, A1 dash and O dash is now your true length. So keep the pencil leg at A1 dash and the steel leg of your compass at O dash. Draw a line from over here. This point is marked as O. Now with this much as your radius, that is the true length of the slant edge. Make an arc. Lovely. Let's start with this very point. Let us say this is A. What is the distance between A and B? Sir, A and B, the distance between them is 30. If you want to check, here it is, 30 millimeters. Lovely. Now with an arc of radius 30 millimeter, right? With A as center, cut an arc. B as center, cut an arc. Keep on repeating the process until you reach A again. And now you can join all of these points with the help of straight lines. This is the case of a pyramid. So the base, all of these base points are connected via straight lines. Join them. Now make these slant edges. CO, DBO. Okay. Done. Development is done. If you want to make your work look more professional, keep it dark. Dimensioning. Okay. And the construction stuff, keep it very, very light and grayish. This is the level that you need to achieve. Right? 10 marks. I still can't believe. कैसे दे दिया भाई 10 number के लिए इसको. Okay. And very recently a student sent his question paper to कि सर इसको चेक करके बताओ कि मेरे कितने नंबर बन गए. Actually this problem he failed in the examination in the first semester 2023-24 session, first semester. Okay, and this is that question paper. So he got it checked from another professor. He told me that sir आप भी check करके जरा बताएं कितना नंबर बन रहा है. I told him इससे ज़्यादा नहीं बनेगा. He wasn't passing. मतलब मुझसे चेक कराने से तो और नंबर कम हो गए. So that was the issue. And so yes, मतलब कुछ भी क्वेश्चन पेपर में लिख के आने से, वो स्टेप्स लिखने से नहीं मिलेगा नंबर. You need to make the drawing. Okay. You have to show some accuracy. भाई तो you have to give respect to the subject. नहीं तो गड़बड़ हो जाएगा. Anyways, no lecturing. Now over to the last question. Again, this is a problem based on development of surface of hollow solids. Take a look. This is based on a cylinder and it's for 10 marks. So there is a cylinder, base is circular, 50 mm diameter, height is 70, cut by a section plane inclined at 30 degree to the HP. Cutting plane or the section plane is at an angle of 30 degree with respect to the HP. Okay. And it passes 30 mm from the base along the axis. Draw a development of truncated cylinder. Can be done very easily. Take a look. Here it is. So we're talking about a cylinder. This base radius is not given, rather the diameter is given. Although diameter is 50, the radius has to be 25. axis is 70. Here it is, right? Cut by a section plane. SP, section plane 30 mm with respect to, sir, HP. Done, sir. Cutting plane is such that it passes the axis at a height of 30 mm from the base. Please, you need to remember this. Okay, let's start. If the cylinder is resting with its base on HP, the true shape of the base can only be seen from the top, and therefore we are going to kick off with the top view like this. Go for 8 divisions. You can also go for 12 divisions. I don't give a damn. Okay, I want to put less efforts. That is why 8 divisions. Now project 1 dash, 2 dash, 8 dash, and so on. You know the stuff. What is the height? I believe it is 70. Yes. Close it. Now you need to make a cutting plane in such a fashion that it cuts the axis at a height of 30 millimeters. So this is what you need to do. Similarly, simply make a point over here at a height of 30 millimeters, and then keep your protractor this, and then at an angle of 30 degrees mark a point and then draw it. Okay, this is going to be your section plane. And as you can see that there is one generator, hence one cutting point. That there are two generators, 2 is in front, 8 is behind, so B dash and C dash, 2 points for 2 generators. Similarly, you can understand all the remaining cutting points. Okay, now you know very well the development of a cylinder is on a very basic level. If it is not being cut by any section plane, is a rectangle, the base of which is equal to pi d. Pi d, that means pi into 50, which approximately will be equal to 157. So this has to be 157, and you know how much this is, equal to this height of the cylinder. Okay, done. Now as you can see that this has been divided into 8 equal parts, so you have to go for 8 divisions here also. Draw a line randomly, any length, any angle, I don't give a damn. Keep your compass. Don't use a compass. You guys can simply make points 10 millimeters away, this way. Don't use arcs, use points. I have to make arcs. Join with the end point of the line. Keep your drafter this way. Tighten the screw, bring it to the 7th point, draw a line, 6th point, draw a line. Keep on repeating the process until all the points are exhausted. Number them from 1 to 8 and back to 1. Done. Lines. Done. Easy. Lines from all of these cutting points, wherever they cut the generator, horizontal. Now, point A is above 1. So this corresponds to A. Secondly, B is above 2, whereas C is above 8. So here, precisely at this location, there is point B and C is over here. Done. Very easy. In the same fashion, D is over 3, whereas E is over 7. You'll realize this horizontal line. Above 3, you've got point D, and above 7, you've got point E. Okay, and I'm sure you can find the remaining points in this fashion. And since this is a case of a cylinder, all the points should be joined with the help of a smooth curve like this. And if you want to see the dimensioning, the construction work, how light it should be, and the outlines, how bold they should be, it would look like this. This is the final work. Development of surface of a hollow truncated cylinder. This is the truncated cylinder. Okay, I hope that I have made myself absolutely clear. And the last 3 problems, in fact, of this question paper, problem 6, 7 and 8, they were rather very easy. Can be cracked in less than 45 minutes, to be very honest. Okay, so yes, if you want to enroll in my courses, take a look on my application. You can download it and install it. And if you want to the PDF, this entire question paper is inside the engineering drawing course, right? Inside that there is going to be a university folder. Go inside it, there is a special folder for Pune University SPPU. You can find it. Thank you very much, and all the best for your examinations.